Hi, I am Rahul Mondal. Welcome back to my channel Learner Tube. Today we will discuss on refraction. Now what do you understand by refraction? Bending of light ray at the surface of separating two different mediums. Now mainly there are two types of propagating medium. First, rarer medium. Speed of propagation is high, and denser medium. Speed of propagation is low. Now we have to know the two laws of refraction. The ratio of sine of the angle of incidence and sine of angle of refraction is constant. Sin I by sin r equal to constant. The incident ray, refracted ray and the normal to the interface of any two given mediums all lie in same plane. Rules for bending of light. If light ray travels rarer medium to denser medium, light ray bends towards the normal. Here PQ is the separation line and MN is the normal on surface. Here AO is incident ray. If light ray would not bend, then it could take path OC. But light bends towards normal and take path OB because of refraction. Denser medium to rarer medium. Light ray bends away from normal. If AO is the incident ray, light ray would not bend, then it could take the path OC. But light ray bends away from normal and take path OB because of refraction. If light ray incident normally on the surface, then there will be no bending of light, whichever the medium is. Now refractive index. It means the measure of how much light changes its velocity when it goes into a new medium. Symbol of refractive index is small n. Small n equal to C by V. C speed of light in vacuum and V speed of light in medium. Example. Refractive index of glass is 1.5 means the speed of light travels 1.5 times slower in the glass than in a vacuum. Refraction through a glass slab. Here we see a glass slab. AB is incident ray. If light ray would not bend, then it could take path AG. But light enters from rarer medium to denser medium. So the ray of light bends towards the MN normal and take path BC. Now at the point C, light enters from denser medium to rarer medium. PQ is normal at the point C. So light bends away from normal and take the path CD. And the distance DZ is called lateral displacement. And CD parallel to AG. Refraction through a prism. If EF the incident ray and PQ is normal on the surface AB at the point F, light enters from air to glass, that means rarer medium to denser medium. So it bends towards the normal. If light ray would not bend, it would take path EH. But for refraction, it take the path FR towards the normal PQ. At the point R, light emerges from glass to air, denser to rarer medium. So light bends away from the normal MN and take path RS. Critical angle. Light enters from denser medium to rarer medium. The critical angle is the angle of incident for which angle of refraction is 90 degree. light must travel from the optically more dense medium to optically less dense medium. For this diagram, incident angle theta and refracted angle is 90 degree. So theta is called critical angle. Total internal reflection. If the angle of incident greater than the critical angle theta, the refracted ray will not emerge from the medium but will be refracted back into the medium. This is called total internal reflection. In this diagram, AO is incident ray. Angle of incident greater than critical angle theta. The light ray reverts back to the same medium and follow the laws of refraction. That's why the phenomenon is called total internal reflection. Here the condition for total internal reflection. Light is traveling from an optically dense medium to optically less medium, and the angle of incident is greater than the angle of critical. Calculation for critical angle. Sin theta equal to 1 by refractive index of denser medium with respect to rarer medium. Example. Consider light travels from glass to air. Refractive index of glass with respect to air is 3 by 2. So sin theta equal to 2 by 3. Theta equal to sin inverse 2 by 3, nearly equal to 42 degree. So the value of critical angle for the glass to air medium is 42 degree. Consider light travels from diamond to air. Refractive index of diamond with respect to air is 2.4. So sin theta equal to 1 by 2.4 and theta will be 25 degree. So the value of critical angle for diamond to air medium is 25 degree. Here we see that the refractive index would high when the critical angle would be low. Factor affecting critical angle. Refractive index. If refractive index increase, critical angle decrease. Temperature. If temperature increase, the medium becomes less dense. So refractive index N will be increase and critical angle theta will be decrease. Wavelength. If wavelength increase, refractive index N decrease, so critical angle theta will be increased. Refraction through a right angle isosceles triangle. Here we see the ABC triangle is a right angle isosceles triangle where AB equal to BC and angle ABC equal to 90 degree. In this case, PR is incident ray. Light enters normally on the surface AB, so it does not bend and take the path RO. But at the point O, RO is incident ray, MN is normal to O, and angle RON is 45 degree. That means greater than critical angle. So total internal reflection will take place. So light ray reflected back by OS path and OS enters normally on BC and light ray emerge by the path SQ. So incident ray and emergent ray are perpendicular to each other.